Hello friends, this is Priyanka. Today we are going to solve a problem on bypass factor of heating coil with the help of psychrometric chart. So in this video we are going to find out dry bulb temperature of air leaving the coil, wet bulb temperature of air leaving the coil, relative humidity of air leaving the coil, and sensible heat added to the air per kilogram of dry air. So first I will read what is the given problem. The atmospheric air at 760 mm of Hg, dry bulb temperature 15 degrees Celsius and wet bulb temperature 11 degrees Celsius enters a heating coil whose temperature is 41 degrees Celsius. Assuming bypass factor of heating coil at 0.5, determine dry bulb temperature, wet bulb temperature and relative humidity of air leaving the coil. Also determine sensible heat added to the air per kilogram of dry air. So this was the given problem. So let us first understand what is the structure of this heating coil. So if we observe what is the data that is given related to air at the entrance of the coil. So this is the entrance of the coil and we will consider here the point 1. So when the air is admitted into this coil, the dry bulb temperature is given 15 degrees Celsius and wet bulb temperature is also given, that is 11 degrees Celsius. So we will consider here the air is equal to 1 kilogram that is getting entered into this coil. So what is happening? So this air is getting splitted. So out of 1 kilogram, x kilogram of air is getting bypassed here and remaining 1 minus x kilogram of air passes over this coil. And for this coil, when air passes over this coil, what is the temperature that is given? That is 41 degree Celsius. And here the bypass factor. Bypass factor means this x is equal to 0.5, that is also given. And here at the exit of the coil we will consider that the point 2. So this is the given data that we have to understand with the help of this diagram. Now we will write here what is the initial condition of air entering the coil, that is at point 1. So dry bulb temperature and wet bulb temperature 15 degrees Celsius and 11 degrees Celsius that is given, and air at heating coil. So at heating coil we have to consider the point 3. So dry bulb temperature is given, that is 41 degrees Celsius, and bypass factor, that is BPF, is given, that is 0.5. So now we will plot the point 1. So with the help of dry bulb temperature and wet bulb temperature, we have to plot the point 1. So dry bulb temperature is given 15. So here is the, on this horizontal line, dry bulb temperature is given in degrees Celsius. So we have to draw here a vertical line. So with this red line we can understand. And now the wet bulb temperature. So along this inclined line, if we observe wet bulb or saturation temperature in degrees Celsius is given. So we have to mark here the line parallel to this wet bulb temperature, but it is equal to 11 degrees Celsius. Now here the point of intersection will give us the point 1. So here is the point 1 that we have to select. Now what is the condition that is for the point 3 is given. So dry bulb temperature at the coil, that is at point 3, is given, that is 41 degree. So we have to draw here one line for this 41 degree. Now how to select the point 3? So we have to keep the specific humidity constant. So along this vertical line, the specific humidity is given, and with reference to this point 1, we have to keep the specific humidity constant. That means we have to draw here the horizontal line, and this dry bulb temperature line, that is for 41 degree Celsius, and this horizontal line intersect at one point, and that will be our point 3. Now we will also find out what is the enthalpy at this point 1. So how to measure? So along this inclined line the enthalpy is given in kilojoule per kilogram of dry air. So we have to draw a parallel line but passing through this point 1. So here with the help of green line we can understand that. And what is the value of H1? So H1 is equal to 31.8, and we have to use the same unit, that is kilojoule per kilogram of dry air. Now what is the dry bulb temperature of air leaving the coil? So for that is the dry bulb temperature at point 2, we have given here what is the bypass factor. So bypass factor, to calculate this bypass factor we have one formula in terms of dry bulb temperature. So this bypass factor, that is x is equal to 0.5. So we can observe here with reference to this point 1, 2 and 3 we can write this formula. So TD3 minus TD2 divided by TD3 minus TD1. So here is TD1, and now we have to put the values. So 41 minus TD2 divided by 41 minus 15. So here it should be TD1. So what is the value of TD2? That is the dry bulb temperature at point 2 is equal to 28 degrees Celsius. That is after calculation. Now again we can plot this point 2 because here TD2, that is dry bulb temperature at this point 2 is known. So we have to select the point with a dry bulb temperature 28 degrees Celsius. So here we have to draw a vertical line and it intersect to the specific humidity line. That will be the point of intersection, will give us the point 2. And now we have to find out what is the enthalpy at this point 2. So here is the enthalpy and these lines are the enthalpy lines. So we have to draw a parallel line but passing through this point 2. So what is the enthalpy at this point 2? That is 46 kilojoule per kilogram of dry air. Then we will find out what is the wet bulb temperature. So what is the wet bulb temperature at this point 2? So if we observe this point 2, again we have to extend this point parallel to this wet bulb temperature. So here 10, 15, 20, these are the wet bulb temperatures. So passing through this point, if we extend this line, then we will get here the wet bulb temperature, that is 16.1 degree Celsius. Now again we have to find out what is the relative humidity at this point 2. That means relative humidity of the air leaving the coil. That means at this point 2 what is the relative humidity. Now if we observe here the relative humidity for this point 2, so here is 20%, here is 30%. So this blue inclined line indicates the relative humidity. Now for this point 2, the relative humidity is 29%. So we have to write this data in detail. So what is the wet bulb temperature of air leaving the coil? So leaving the coil means what? We have to refer the point 2. So TW2 is equal to 16.1 degrees Celsius. Relative humidity, that is phi 2, is equal to 29%. Now we have to calculate sensible heat added to air per kilogram of dry air. So how to calculate it? That means sensible heat added. That means we have to take the enthalpy difference. So point 1 is the entrance point and point 2 is the exit point of the coil. So we have to take the enthalpy difference H2 minus H1, which is equal to 14.2 kilojoule per kilogram of dry air, because here the value of H1 31.8 and what is the value of H2, that is 46 kilojoule per kilogram of dry air. So if we take this difference we will get the answer 14.2 kilojoule per kilogram of dry air.